Here we go.
That's good. That's a good point. Okay. Well, hello everyone. I'm Georgi, and I'm going to present this work titled "What Makes You Change Your Mind," which is a study of how people in groups make decisions together. So myself and Andreas are from the University of Cambridge, and Tom Stafford is my second supervisor, who is from Sheffield. And all of this work is part of a larger DailyBot project, we call it. So before I start, typically an academic presentation contains two things: why we did the thing and how we did the thing. And more often than not, the why is not very important, or at least it didn't receive its fair amount of time in a presentation. So, but in this presentation, I'm going to spend some time in why we actually did this work. So we're talking about group decision making, how people collaborate together, and this is actually something that has been studied in psychology quite extensively, and for good reason. When people work together, they make better decisions together, and this is shown. People engage in group discussions in their everyday life, in project meetings, supervisor meetings, hiring panels, what have you. And psychology has shown that if you give people a task and they have to solve this task on their own, for some of these tasks, they perform quite poorly. They perform correctly in 10 to 20% of the time. But if they work in groups, that performance could be up to 70 to 80% performance on average. 70 to 80% performance on average. And this has various names. Mercier and Sperber call this the assembly bonus effect, or kind of the old saying like the group is better than the sum of its parts. And Navajas kind of showed that deliberating or collaborating in small groups is outperforms the wisdom of the crowd if you just gather thousands of people have them vote, which is clearly shows that there is something that happens in groups. So what makes for a constructive discussion? Also, there is some research in this area. Could be if you advocate well for a certain solution, or if you disagree with each other, which actually is quite a strong marker. If you propose an opposite or alternative solutions, or if you try to probe the conversations to ask more questions, all of these things can help. So with that in mind, we studied the Wayson card selection task, which is a task from psychology where people have to select which cards to turn in order to prove a rule, where the rule is all cards with vowels on one side have an even number on the other. And I won't go too much into the mechanics of the task, but it exploits the confirmation bias, and people usually, as it is in this discussion started with, the answer is U and 2, which is the wrong answer, but the most commonly given answer. And they engage through various patterns, and then they settle on the correct answer, which is U and 7, the vowel and the odd number. And this is kind of a very classic setup of the Wayson card selection task. And the key question is, okay, people do it and people solve this task. Can we introduce a dialogue system within this group discussion to make them solve this task better? To make this group the best performing group that we have in the set, not just the group that on average may perform better, but a group that is certainly one of the best. And here we introduce the concept of the DailyBot, which is a dialogue system for group deliberation. And if we have a dialogue system that kind of acts as a moderator, asks questions, asks people to explain their reasoning, or to propose an alternate solution, or not to propose, but to question an alternate solution. The moonshot question is, will this work? Will this dialogue system help people perform better? So here we have plenty of people who work on task-oriented chatbots, probably a couple of winners of the Alexa challenge. So we could just approach this as a task-oriented system. I mean, nothing new under the sun. The good thing is that the task is trivial. If you do this as a task-oriented chatbot, you could just say, okay, the bot introduces itself and say, yeah, this is the answer. And the group answers it, and it's all good. The problem is, if a chatbot solves the problem, is this really a constructive discussion? And the answer to that is, of course, no. The other thing is that people can lead constructive discussions on a variety of topics. And however we expand the chatbots, the task-oriented chatbots, they're still not there to be the general purpose, knows answer to everything in life, and yeah, generally everything. And if we consider the option where we have a panel, we have a hiring group, typically there is a person there who acts as a moderator. And a moderator can participate in wide range of discussions without actually being an expert in the field, but the moderator can still help the discussion. So with that, daily bots. The main goal of these are to increase the performance of a group. If they solve a task, they have to solve it better with the daily bot in it. It doesn't know the answer. It knows how to ask good questions. It is, so to speak, a moderator of the group. Kind of the slight paradigm shift is that we don't have a goal of a dialogue, but the good dialogue is the goal. And the shift is not to complete a task for the person, but to provide a framework that helps people solve the task on their own. And now, as an interlude to the paper, I'll talk a bit about the data that we use. It's collected in previous work, but it's essentially 500 dialogues collected of people solving the weights and card selection task. Group dialogues, average of just about three people in the group, and having about 14,000 utterances. And for 50 of those dialogues, we annotated them with a schema. I won't go into too much detail, but there are a couple of important things here. One is, well, the probing versus non-probing. Probing is certainly something that we would want a future daily bot to say, and non-probing is all the rest. And the other two key bits is this complete and partial solution, which is markers which indicate whether someone advocates or proposes a solution. And this will be important in just a minute. Some stats, that's not important. So if we have an annotated dialogue, the dialogue from before, we can see that the daily bot will be the probing, it could be moderation, it could be concept reasoning. And when someone proposes a solution, it's marked as complete solution, or if they propose part of the solution, partial solution. So let's build the daily bot, and the question is how. We could train on all of the data we have, train the same way we train dialogue systems of any kind. But the first problem is turn taking, which is a challenging task by itself. But when it's in a group discussion, it's slightly more challenging. So when should the daily bot speak? Ideally, if the conversation is going well, if you have a panel and conversation is going well, a moderator doesn't intervene in the conversation. It's just going well, right? All good. But if something is going poorly, a skilled moderator knows when to intervene and what to do. So that's the first problem we have to solve. And the second problem is what the daily bot should say. So an easy solution, having the annotation schema, we can just train on all probing utterances and ask the bot to say, yeah, based on the context, that's the probing utterance I have to say. The problem is that actually not every time someone intervenes in a conversation with a probing question, that's helpful. Sometimes it's not helpful at all. So we need a way to understand what is helpful and what is not. And back to the paper. So that's the why. We have two problems. We have no idea how to solve them. We try to solve them with investigation of how people change their mind in a conversation. So imagine this conversation. I'll quickly explain the graph. So on the x-axis, we have well, the amount of time of the conversation with the dots is, let's say, each utterance. And on the y-axis, we have an approximated performance for each utterance. So it kind of looks like a graph of something that's of some process that's happening which is a representation of how well the conversation is going. So ideally, if we can predict that the performance of the conversation will deteriorate and we intervene before that, that may be something that we would like to do. Or if we see that the performance is not going up by itself, maybe we should intervene here so we can improve the performance of the group. So that's kind of the goal of the timing portion of the paper. And then the other thing is how do we find good things to say? So this graph is a bit overloaded, but I'll try to simplify it. So with an orange line, is this the performance graph I've shown you earlier? And with different bow ties and stars or different probing labels that we have from the dataset. So we can see that from some of them, after that, the performance deteriorated. Maybe those are not good labels, but after some of them, the performance improved. So maybe these are good ones. So the question is, how do we find these labels when the data is not annotated? And this brings us to the task definition. So in this paper, we are trying to investigate which are the utterances that will make someone to change their mind. And just as quick note, this is online detection. We don't know, we don't train the model on what was said after someone changed their mind or when they changed their mind. It is an online detection. We try to predict proactively before someone expresses a change of mind. And this is easy to demonstrate with the graph. So if you have a conversation and someone expresses a change of mind, says, okay, let's do this, this, and this, we can assume that the utterance before that, and it is an assumption, that the utterances before that caused that change of mind. So we're trying to predict that cause. And likewise, it could happen more than once in a conversation. So back to the data, we have this 500 dialogues, 50 annotated, 450 unannotated. The key bit for the unannotated dialogues is that we have some game data. For example, when someone played the game and they pressed the revise your current solution button, we have this recorded, and we know when someone interacted with the system in a way. So it is not completely unannotated, but it's not really with gold annotations. And then we can create a test set and a training set. A test set is trivial. We use the annotated data. When someone is expressing a change of mind, we say that the previous utterance is the cause of that change of mind. It's slightly less trivial for the trained data where we don't have annotations, but we use game submissions, and kind of the main assumption is if you have a game submission, the last utterance that was not said by the same person make them change their mind. Assumption again, but it is what we work with. And the kind of purely the stats for the 50 annotated dialogues, we have 262 annotated changes of mind, and for the rest of the dialogues, in 220 of them, we had more than one of revised submission, so they have more data, and in these we have about 1,200 changes of mind. So how do we do this? Let's have a quick exercise. I guess the answer, but is there anyone in the room who is reliability engineer or mechanical engineer of sorts? No. Anyway, reliability engineering. If you look at some data from a sensor in a machine, you can use this data to predict when this machine should be serviced or when it will break down. And this is the entire field of studying reliability engineering, trying to predict when something will break down or when an event will occur. And they have plenty of methods to do this. I won't go into the maths behind each of these models, but I'll try to explain the intuition. So the first one, very simple, hazard function. The longer the process goes, the likelier for a change point to occur. If you have a machine that's working, the longer the machine is working, the likelier it is for the machine to break down. Easy. Problem with hazard function, it records time from the last change point, from the last breakdown. It doesn't record the whole lifetime of an event. And with that in mind, we have the positional prior, which essentially something, a very simple probability that we included in addition to this, which says, okay, sometimes changes of mind or change points could happen at very specific points of the conversation. Maybe people change their mind at the end of the conversation, not at the beginning. So we just encode this global positional information with this positional prior. And finally, the actual more sophisticated method is a work introduced by Adams and McKay, which they call Bayesian online change point detection, which takes into account the hazard function, the probability of this stream of data to occur, time since the last change point, and all of this is kind of incorporated in a couple of terms. But the problem with it also doesn't record any global positional information. So for example, if a change point occurs here, it starts counting from 0 afterwards, and it forgets everything that happened here. So if you have some specific knowledge that, for example, change point may occur in later points or in the earlier points in the global lifetime, this is not encoded with this model. And then we have text-based models. We are working with dialogues. We can't just rely on kind of very raw data. So the simplest way to do is just take, if we have this context, and we know that there has been a change of mind, we can say, okay, we concatenate these two utterances. We say this is a change of mind. We train a model. I won't bore you with the details. Simple transformer model out of the box. You train it on your data. You see how it works. Spoiler alert, it doesn't work well. The next thing that actually works is learning to rank. So we have class imbalance, we have similar utterances, we have all kinds of stuff in our data. So one thing we could do is actually ask for a model to predict whether one pair of utterances is more likelier to cause a change point than the other pair of utterances. And there are some interesting tricks in the paper, like you can select one positive or one thing that changes someone's mind. And because it's an underrepresented class, for each epoch, you can rotate the negative class to that. You can do some cool things to regularize the whole thing. But essentially, it's a simple rank net loss, which trains a pair of models to try to rank this. And just quickly on evaluation, because that's also not entirely trivial. How do we want to evaluate? Simple case, we want to evaluate exact matches. If there was a cause of change of mind and we predicted the cause of change of mind, that's exact match. Good. We encountered cluster matches. Sometimes causes of change of mind are clustered together and the predictions of the model are clustered together. In order not to inflate this model to kind of give more credit than it's due, we consider these clusters and we give only one credit for predicting a cluster. And if they're off by 1 errors before the cause of change of mind, we can say, okay, this is partial match, or it's predicted before that. That's good. But if we predict after the change of mind, we don't give credit because that's a trivial task. It's easy to detect when someone changes their mind. When someone says, yeah, I think the answer now is this and this. So results, baselines. Everything is a change of mind, quite poorly. Kind of the easiest thing out of the box that you can do, bug reports, random forest, TF-IDFs, what have you. Slightly better, reasonable performance out of the box. So now if we add the language agnostic features, so everything from reliability engineering. Hazard function, better than the baseline, worse than random forest. Positional prior, better than the baseline, better than the hazard function. Flat. Bayesian online change point detection, very well researched, very complex model, slightly better. And combining the Bayesian online change point detection with the positional prior is actually the best language agnostic model, and it works quite well given the baselines that we have. Okay, now the text-based model. We have two models: simple neural model, which performs on par with the bug reports around the forest case against transformers. But then there is learning to rank, which for some of the measures performs quite a bit better than the baseline model. And overall, a feature combination is what works the best. Essentially, if you combine a learning to rank with the data that is encapsulated from the Bayesian online change point detection and some positional information, this is actually the thing that kind of moves the needle the most. And now that I have 1 minute left and all of you are on the edge of your seat about wanting to be kind of part of this project, I will have two or three things to say on what's next. So one is we're working on the daily data 2.0, where all the 500 conversations will be annotated. But before that, explore the current version. We spend a lot of resources on that. So if you work on a similar field, that would be helpful. We're organizing a Deliberation for Good workshop next month. in Cambridge free workshop, we'll talk about all kinds of ways of people, how they make better decisions together with people from politics, psychology, and computer science. And if you want to speak or present something, please reach out. And finally, I'm happy to answer any questions. 20 minutes on the go, by the way.
Yeah, great talk, first of all. So I was wondering, so in terms of soft penalty of, I think you presented 4 metrics. So for like penalizing the intervention when it's not exactly matched with the gold thing. So did you experiment with any other kind of, first of all, I just wanted to like clarify what the cluster match metric was. I didn't quite get that. And also if you looked at any other metrics for this particular problem.
Well, we tried with kind of first counting exact matches, but it's very, very restrictive. But off by ones are also very a bit too permissive. As I said, it's very easy to predict a change point after it happens. I mean, you can see that something changed, right? So yeah, that's kind of why it's a combination of a couple of methods that were typically used. But kind of this is the method that we devised. It's not entirely, original creation is just a merge of different methods.
Okay, just sort of follow-up question. So it's just more like a general question, but you spoke about how task-oriented dialogue architecture doesn't really fit well with this kind of a scenario, like a standard slot filling kind of an agent. So this appears more like you're trying to solve one sub-problem, which is the kind of when do you, or rather recognizing which is the utterance that changed the mind. But in a bigger picture, if you're trying to build a fully functional end-to-end agent that is supposed to act as a supporting agent in a group conversation, what kind of architecture do you think that would end up looking like?
What do you mean architecture?
So like, what do you think would be like the building blocks of, because I think one of the problems you have is you just have like 450 conversations. So I see like a small data problem there as well. So in many ways, there's so many ways in which it's different from task-oriented dialogue. So if you were to build like an end-to-end functional bot that supports this kinds of collaboration.
The assumption is that there are only so many ways that you can actually probe a conversation or try to moderate a conversation. There aren't thousands of ways that you can do this. But yeah, obviously that's an assumption that the thing that we train on this 500 dialogues will kind of transfer to a different task or to a different, slightly different domain. It's an assumption, something that has to be tested. But there's only so many ways to ask people, what do you think? Or to ask for someone to shut up and to give the word to someone else. I'm hopeful that this would be enough, but if not, yeah, maybe it will require Derridata 3.0, which includes a different task. As it is, it's a very, very expensive and very resource-intensive data set to collect. So I'm not sure whether I certainly won't get funding for more.
Thanks.
Question. So you said it's easy to tell after the fact,
yeah,
and you make the assumption that the previous utterance is the one that changes the mind. And that seems like a pretty good assumption most of the time, but there are a couple of other alternatives. It might be something a little bit further back and it took the person a while, or it could be that they're spontaneously just thinking and they come to their self. So related to the invited talk we had this morning, I wonder if you thought about trying to use discourse relations, like, you had some of them here, like then or actually, or things that relate to the previous utterance, and maybe see if that might improve some of the training data or maybe improve the results.
Well, we experimented with that a bit. One thing we found out that kind of discourse parsing on kind of group dialogues, at least of this kind, just doesn't work well. We were not able to make it work well. And the other, if we have to annotate this, it's very hard task to annotate. How do we know which thing exactly changed some of their minds? The combination of things.
Yeah, I mean, just doing the very specific relation annotation, like taking the the point where they express the change of mind and say, what is this related to and what relation is it? So if it's a, some kind of summation or, some positive relations, you would say that that's the change of mind with, so you don't have to do the whole parsing.
Yeah. I mean, maybe it could work, but at this point we decided to just make assumptions and try to make this work with the kind of the resources and the data we had. Maybe it could work if we try to introduce something like that, but not sure. I haven't tested it.
Any last questions?
Hi, it's Veronika Sienińska from Harriet Watt. It was a very interesting talk, thank you. So I understand that you only experimented with one bot plus humans collaborating on a task. Have you also experimented with adding another different bots? And if not, are you maybe planning to do it? A collaboration between two different bots on a task?
I had this idea at the beginning of the beginning of this project. What if we just put multiple bots and they try to work together? Or what if we have bots that are trying to solve the task and bots that are trying to help to solve the task? But at the end, maybe someday I'll explore it, but I'll try to now just kind of focus on one bot, multiple humans, no kind of multi-agent collaboration, but likely multi-party collaboration.
Okay, thank you.
Thank you, speaker.
Okay.